Next unit, you will need to create a TinkerCAD account. In order to do that, open a new tab and go to tinkercad.com. Once at this site, click Join Now. You want to create a personal account. Sign in with Google. You should be able to use your school account for this. Once you're signed in, you should be at this site here. We're going to use TinkerCAD for circuits. Select circuits and create a new circuit. First, familiarize yourself with all the components on the right-hand side. Note that you can use basic components such as resistors, LEDs, potentiometers, push buttons, batteries. There's even some motors you can play with and other sensors. You can also search Arduino components. There's different circuits and Arduino boards that you can select from. You can also type in a search. You could search for things like breadboard, and you give all size breadboards. The breadboard we will most commonly build from will be a small breadboard. Once you have the breadboard out here, you can drag it around and put it where you'd like. Switch back to basic components, and you can drag out new components. Drag out a resistor, you can drag out an LED, whatever you need to build your circuit. We're going to start by building a very basic circuit involving a battery, a resistor, an LED, and some wires. Notice each component, when you click on it, gives you some editing options. For instance, I can change the value of a resistor, I can change the color of an LED, I can change the power of a battery, I can change the type of battery, I can change how many batteries. For this example, let's do 4 AA batteries. This would be a total of 6 volts, 1.5 plus 1.5 plus 1.5 plus 1.5. Let's now show you how to add some wires. This black wire is negative and should be brought to the negative part of your breadboard. Select any hole in this negative row, indicated by the negative sign, and drop a wire. It's also a good idea to color code your wires. So when this wire is selected, I can now change it to the color I want. Black is always negative. I can also add a positive wire. Again, select any hole in this red positive row as indicated by the plus sign. And again, with the wire selected, select red. Our breadboard now has power. Now let's put our LED in. Your LED can be dropped anywhere you'd like on the breadboard. And note that you can also rotate components if you choose to do so by using this feature up here in the top corner. The LED will rotate around. Make sure wherever you drop it, it is actually snapped into 2 holes. You can put it up here as long as it's snapped into those 2 holes. Then we're going to add our resistor. For this circuit, let's use a resistance of 1000. Right now this is 1 and the K indicates 1000. If I did 100 and left it as a K, that's 100,000. That's now 100 ohms. I put 1000 here. 1000 ohms is the same as 1 K ohm. Okay, notice the color. Brown, black, red. 1,000 means K. Could also have it written like this. 1,000. And again, brown, black, red. So for this example, we'll use 1,000 ohms. So either 1,000 ohms or 1 K ohm. It's the same thing. Drag your resistor onto your breadboard and be sure to rotate it so that it is horizontal. Make sure the one leg of the resistor is in the same column as the LED. That's how breadboards work. Anything in the same column is connected. So do you see how all these light up green? Anything in that column will be connected. So right now, the only things we have connected in our circuit would be the resistor and the LED. All we have to do now to get this circuit working is to add a wire from our negative of the battery to the negative of the LED. The color for this doesn't necessarily matter, but if you wanted to keep things consistent, it'd be a good idea to make it black, indicating that's going to the negative side of the LED. The only connection we're missing now is to get back to the battery. So we need to add a wire from the resistor, which goes to the positive side of the LED. We need to add a wire to this column and connect it to the positive terminal of the battery. And again, it'd be helpful to make this one red, indicating positive. At this point, we can start our simulation. To start your simulation, you click this button right here. I start it, and you can see that the light turned on. If I stop it, I can go back in and make changes. Watch what happens to the light if I use a lower resistance. Let's say only 100 ohms. Last time we ran it at 1,000 ohms. Now we have 100. Again, if I start simulation, notice the light is bright, and it actually is giving me a little warning message that it might explode because we have too much volts. Let's stop the simulation and edit the resistor one more time. If I make it 5,000 ohms and again start the simulation, notice the light is very dim. Let's stop the simulation, change the resistor one more time. 10,000 ohms. Start the simulation. Notice the light barely lights up. That's because the higher resistance, the less electricity is going to go through our LED.